Let's take a look at molality now. Molality and molarity are extremely close to one another, and we want to point out the difference of why that might be. Now, first of all, it's kind of weird, but they always write in a textbook version that the molality is expressed rather than molarity, which was just a capital M. We use a lowercase italicized m. So this is what I'm doing, is I'm making kind of a cursive M. It's kind of weird. It's how we express molality in a problem. The difference, or the similarity, I should say, is that they're always going to be describing the moles of solute that's present in a solution. Okay, so that's always constant. That's the same for molarity and molality. The difference is right here. Your molality is pre-measuring your solvent. Most often that's going to be water, and we measure it in kilograms. So take a look at the differences. You're going to pre-measure everything rather than simply add until we have a certain amount or volume of a solution. Remember, with molarity that was in liters, but here in molality we're going to actually be talking about just the solvent, not the solution total. So here's what it looks like in action. The question is, what is the molality of a solution if 200 or 750 milliliters of water is added to 3.5 grams of calcium sulfate? Now, remember, grams we need to get into moles. So let's take a look at that first. 3.5 grams of calcium sulfate. The question is, how do we convert that into moles? Okay, so grams to moles of calcium sulfate. All right, let's show our work. 1 calcium, 1 sulfur, 4 oxygen. This is 16, this is 32, and this is 40. So this is 40, that's 32, and this is going to be 4 times 16. What is that? 64. So my final mass for that ends up being 136 grams for every 1 mole. Now, that is going to give me a long answer in my calculator, and so you're going to get an answer of 0.0257 blah blah blah. Okay? Now, keep that in your calculator because that goes right up here for this number. Keep it in your calculator because I know 750 milliliters of water is the same as 0.75 kilograms. 1 gram is 1 milliliter. So if I just keep this in my calculator, I just say divided by 0.750 kilograms of water. So you never clear this out, you just leave it right in there. You ended up with an answer of 0.0343 molal solution. Okay, now 2 significant figures, so then we would just go 0.034 molal. Pretty easy. You just kind of follow it that way. Let's take a look at this next example. How much water must be added to 175 grams of sodium chloride to make this strong? So 2.75 molal equals X moles of sodium chloride over, oh, I'm sorry, we have 175 moles. So we don't know how many moles that is yet. Okay, but this is going to be my X liters of water. Okay, when they say how much, just leave it in liters. Okay, so the question is, how many moles is that? 175 grams of sodium chloride. Okay, let's go grams to moles. 1 mole, so we have 1 sodium. Well, I have 1 chlorine. Chlorine is 35.5. Sodium is going to be 23. And so if I add that up, 23 plus 35.5, that ends up being a final mass of 58.5 grams. Okay, so I take 175 divided by 58.5. I ended up with an answer of 2.99145. Now, that's how many moles of sodium chloride. Now, you can go ahead and keep this number in your calculator as well, because if I were going to get X by itself, I multiply both sides by X. Okay, that gets it out of the denominator. And then I'm going to take this answer that was in your calculator already, divided by your 2.75. That's what I do to get that by itself. So even though it's messy, I'm just showing you how this works. Keep that number in your calculator, then you don't have any rounding errors or anything like that. And I ended up with an answer of 1.0878 kilograms, which again, if I go in this case 3 significant figures, 1, 2, 3, I have 1.09 kilograms of water. Okay, so the problem's actually pretty simple. You're just solving for X and just getting it into that formula.